Welcome to another episode of AI Talks with Chris and Nita.
Great to be here.
Today we're tackling something pretty fundamental if you want to understand how AI models actually learn. We're talking about epochs, batches, and iterations.
Yeah, these terms pop up all the time in AI training discussions. We thought we'd do a quick deep dive to really clarify what they mean and why they matter.
Exactly. Think of this as your shortcut to getting a solid handle on the core mechanics of training. Let's jump right in. Epoch. What is it in simple terms?
Right, so an epoch, well, it's essentially one complete pass through your entire training data set.
The whole thing. Every single piece of data.
Every single piece. Imagine you've got, say, 1,000 photos to train an image recognizer. One epoch means the AI looks at all 1,000 of those photos once.
Okay, and why do that? Why does it need to see everything in one go? What's the goal of an epoch?
It's about allowing the model to see the bigger picture, to learn the overarching patterns that exist across all the data.
Not just focusing on tiny details yet.
Exactly. As it goes through the data, it updates its internal settings. Think of them as its knowledge, weights, and biases based on the errors it makes. Seeing everything helps it grasp those fundamental relationships.
Got it. So one epoch, one full look at all the training material. But, data sets can be massive these days. Trying to process everything at once sounds computationally heavy.
It absolutely can be, and that's precisely where batches come into play.
Okay, so batches are the solution to the size problem.
Pretty much. Instead of feeding the entire data set to the model at once, which might overload your computer's memory or just take forever, we divide it. We chop it up into smaller, more manageable chunks. Those chunks are called batches.
Right, like breaking a huge textbook down into chapters. Makes sense for processing. Does it change how the model learns, though? Learning chapter by chapter versus the whole book at once?
It does, actually. The model updates its internal settings, its weights, after processing each batch, not just at the end of the entire epoch.
Oh, interesting. So more frequent updates.
Yep. So if you have, say, a data set of 1,000 samples, and you set a batch size of, let's say, 50.
Okay, 1,000 samples, batch size 50.
Then you'd have 1,000 divided by 50, which is 20 batches.
20 batches to make up the whole data set. So the AI processes 50 samples, updates itself, processes the next 50, updates again, and so on 20 times.
Exactly. 20 times within that single epoch. It allows for faster feedback loops during training compared to waiting until the entire data set is processed.
Okay, so we have epochs, the full pass, and batches, the smaller chunks within an epoch. Where does iteration fit into this? Sounds similar.
It's closely related. An iteration is simply one pass of a single batch through the model.
So in our example with 20 batches.
That means there are 20 iterations per epoch. Each time the model processes one of those batches of 50 samples, that counts as one iteration.
Got it. So iteration is tied to the batch processing step. If we decided to run, say, 4 epochs.
And you still had 20 batches per epoch, then the total number of iterations would be 4 epochs times 20 iterations per epoch, which is 80 iterations overall.
Okay, that clarifies the relationship. Epochs, batches, iterations, they're all linked. Now, you mentioned setting the batch size, like 50 in our example, and the number of epochs, like 4. These aren't fixed values, are they?
Not at all. They are what we call hyperparameters. These are settings that the data scientist chooses before training starts. You can tune them.
And tuning them affects the outcome, presumably.
Yeah, absolutely. Especially the number of epochs. You need enough epochs for the model to learn properly.
But not too many. I feel like I've heard about a downside to running too many epochs. Something about overfitting.
Yes, exactly. Overfitting is a major concern. If you train for too many epochs, the model can start to essentially memorize the training data, including its noise and quirks.
So it gets really good at the specific examples it saw during training.
But it performs poorly when you show it new, unseen data because it hasn't learned the general patterns, just the specific training examples. It's like cramming for a test by memorizing answers instead of understanding the concepts.
Right, that makes sense. So how do you avoid that? How do you know when to stop training before it starts overfitting?
Well, a common technique is to use a separate chunk of data called a validation data set. This data isn't used for the actual training updates.
Okay, a separate test set, kinda?
Sort of, yeah.
Yeah.
While the model trains on the main training batches, you periodically check its performance on this validation set.
And you watch how it does on that unseen data.
Exactly. You'll usually see the model's error rate on the training data keep going down epoch after epoch. But at some point, the error rate on the validation set might stop decreasing or even start to increase.
Oh, that's the sign. When performance on new data starts getting worse, even if it looks like it's still learning the training stuff.
That's your cue. It's a strong indicator that overfitting is starting to happen, and it's probably time to stop the training process. This is often called early stopping.
Okay, fantastic. So just to quickly recap and make sure we've nailed it down, an epoch is one complete pass through all the training data. A batch is a smaller subset of that data, used to make processing manageable and allow for more frequent updates.
Yep, manageable chunks.
And an iteration is simply one pass of a single batch through the model. So the number of iterations per epoch equals the number of batches.
You've got it. And the batch size and number of epochs are key hyperparameters we adjust.
Perfect. Understanding this really does demystify a lot of what goes on under the hood during AI training.
It definitely gives you a clearer picture of the learning process itself.
Absolutely. So here's something to maybe mull over. We talked about how the batch size changes, how often the model updates itself within one epoch. Considering that, how might using really different batch sizes, like tiny batches versus massive ones, ultimately shape the kind of intelligence or generalization ability the final model achieves?
That's a great question to ponder. The frequency and scale of those updates definitely play a role.
Definitely food for thought. Thanks so much for this deep dive.
My pleasure.